So in this problem, we have to find the maximum and the minimum distances of the point 3, 4, 12 from the given sphere x squared plus y squared plus z squared equals to 1. So first of all, let us visualize this problem so that we can decide which one is the function to be maximized or minimized and which one is the constant. So we are given a fixed point in space, and suppose this is the point 3, 4, 12, and there is this sphere. So this is a rough diagram of a sphere, and this of the sphere, given sphere. Then this sphere is x squared plus y squared plus z squared is equals to 1. Any coordinate of any point on the sphere will be x, y, z. Now the distance from this fixed point to sphere is, this one is the distance, say we denoting it by d, and we have to find the maximum value of this distance d from this fixed point to the sphere. So we have to maximize and minimize, okay, this function d. So d is the function, and what is the constraint? Our constraint is the sphere. Our constraint is the sphere x squared plus y squared plus z squared equals to 1, right? So now here the function is not directly given. So let us first find the function d using the distance formula. So now we are solving the problem. Solution. The distance of the distance d function of any point on the sphere x, y, z from the fixed point 3, 4, 12, we use the distance formula. So d will be square root of x coordinate minus x coordinate. So this will be x minus 3 whole squared plus y minus 4 whole squared, y minus 4 whole squared plus z minus 12 whole squared, del z minus 12 whole squared. So this is equation number 1, and this is our function. This is our function which we have to be maximized and minimized. And what is the constant? Constant is the sphere. So constant, the equation of constant is x squared plus y squared plus z squared is equals to 1, right? Now since we have to find the partial, we have to use partial derivative of the function, and it will be a bit difficult to find the partial derivative of a square root function. So we square the, so we create a new function f. It is square of d squared, and we will get x minus 3 whole squared plus y minus 4 squared plus z minus 12 squared, and this is our equation number. So constraint is equation number 2, and this one is our equation number 3. Now the good thing is that this squaring will not matter, right? So the points of maxima or minima of this function f will be same as the points of maxima and minima of function d. So now with the help of the given constant, we create this function g, and g will be x squared plus y squared plus z squared minus 1. So this is our equation number 4, right? Now by Lagrange multiplier method, we know that at the points of maxima and minima of this function, f and g will satisfy this equation. Gradient of f is lambda times gradient of z, and we know that this equation is nothing but a bunch of 3 equations. Now in this case there will be 3 equations because we have 3 independent variables x, y and z. So the 3 equations will be partial derivative of f with respect to x equals to lambda times partial derivative of g with respect to x. This will be our equation number 5. Similarly with respect to y and with respect to z. So 5, 6, 7 are our equations which you obtained from the basic equation, gradient of f equal to lambda times gradient of g. Okay. So, and we need one more equation because we have three unknowns x, y, z as well as the parameter lambda. So the fourth equation we already know that the equation of the constraint. So the fourth equation is x squared plus y squared plus z squared is equals to 1. This is our equation number 8. Now to apply equation number 5, 6 and 7, we need the partial derivatives. So f is x minus 3 whole squared plus y minus 4 whole squared plus z minus 12 whole squared. So we have del f over del x is equals to y and z will be treated as a constant. So this will be 2 times x minus 3. Similarly, del f by del y equals to 2 times y minus 4, 2 times y minus 4, and del f by del z will be 2 times z minus 12. Del f by del z, partial derivative of f with respect to z, x and y will be treated as a constant. So this is 2 times z minus 12. And next we need the partial derivatives of g function. So we have del z over del x is equals to 2x, del z over del y is equals to 2y. There is a symmetry in the function, and partial derivative of g with respect to z, this one is 2z. Now we plug in all these partial derivatives into equation number 5, 6 and 7. So from 5 we get 2x minus 3 is equals to lambda times 2x. From equation number 6 we get 2 multiplied by y minus 4 is equal to lambda times 2y, and from equation number 7 we get 2 times z minus 12 is equal to lambda times 2z. And of course our fourth equation is equation number 8, and that is x squared plus y squared plus z squared equals to 1. Now what will be our next step? From these three equations we will eliminate lambda, and by that way we will find y in terms of x, z in terms of x. Fine. And we'll put those x, y, z values in equation number 8. We will get the value of x, y and z. So let us go forward. Now we are dividing equation number 5 by equation number 6. So we have 2 over 2 multiplied by x minus 3 over 2 y minus 4 is equal to left hand side by left hand side, right hand side by right hand side. So we on the left hand side, these we factor out 2 and 2 cancels out, 2 lambda and 2 lambda cancels out. So we get x minus 3 over y minus 4 is equals to x over y. We cross multiply, we get xy minus 3y is equals to x minus y, xy minus 4x. These two terms on the left and right hand side, they cancel out. So we get from here y is equals to 4x over 3. Similarly, by dividing 5 by 7, we are dividing equation number 5 by 7, right? So when we divided equation number 5 by 6, we obtained y is equals to 4x by 3, right? There is a symmetry in this problem. So similarly, we will get z is equals to 12 by 3x. So we will get 12 over 3x. So by dividing equation number 5 by 6, we obtained y in terms of x, and by dividing equation number 5 by again 7, we obtained z in terms of x. We plug in these values of y and z in equation number 8. So we obtain x squared plus in place of y we will put 4x over 3 whole squared plus in place of z 12 over 3 whole squared equals to 1. We didn't simplify this 12 over 3 so that it will be easier to simplify this expression, right? So this by taking LCM 9 we get 9x squared plus 16x squared plus 12 squared 144 squared whole over 9 is equals to 1. And further simplification, x squared comes outside. We got 9 plus 16 plus 144. It is 169. Whole over 9 is equals to 1. And this implies x squared equals to 9 over 169. 169. And we have a square root of, so we'll have, it's a quadratic equation, two values of x. Square root of 9 over 169, so we get values of x plus minus 3 over 13. Square root of 9 is 3, square root of 169 is 13. So we plug in the value of x here. When x is equals to positive 3 over 13, we put 3 over 13 here, 3 and 3 cancels out, we'll get y is equals to 4 by 13. And when we have x equals to minus 3 by 13, the corresponding value of y will be minus 4 over 13. Similarly, when we plug in x here, when we put x is equals to 3 over 13, 3 and 3 will cancel out. So when x is equal to 3 over 13, we will get z equals to 12 over 13. And when we put x equals to minus 3 over 13, 3 and 3 will cancel out, we will get z equals to minus 12 over 13. Okay. So we have two sets of points at which the function will have a maximum value or a minimum value. First set of points is x is 3 by 13, y is 4 by 13 and z is 12 by 13. And the second set of values are x is minus 3 by 13, y is minus 4 by 13 and z is minus 12 by 13. Okay, so let us clear this clutter. So our points of maxima and minima are, the first point is P point and its coordinates are 3 by 13, 4 by 13 and 12 by 13. And second point is Q point, negative 3 by 13 minus 4 by 13 minus 12 by 13. So these are the points at which the function f will either have a maxima or a minima, and by that way the distance function, similarly the distance function d will have a maxima or a minima, right? And we already know that Lagrange multiplier gives us the points of maxima and minima, but it does not gives us the nature of the points. It does not tell me whether there will be a maxima at p or a minimum value at p of the given function. So how to decide that at what point function d will have a maximum value and at what point it will have a minimum value? We simply plug in this point in the given function d, okay, and find the value of d. That p point, we have d at distance function at p point. This will be square root of x is your 3 over 13. We are finding the distance value of distance function at point P. So x is 3 over 13 minus 3 whole squared plus 4 over 13 minus 4 whole squared plus 12 over 13 whole minus 12 whole squared. Okay, now let us simplify it. So from this bracket we can take take out factor 3, so 3 squared, it will be 9, so it will be 9. So inside we have 1 over 13 minus 1 whole squared plus, again in the second bracket we factor out 4 squared, 16 comes outside, 1 over 13 minus 1 whole squared plus 12 comes outside when 144, and inside bracket we have 1 over 13 minus 1 whole squared, right? We are simplifying it, this expression, and this one is equals to, so 1 over 13 minus 1 whole squared is common, so we have 1 over 13 minus 1 whole squared multiplied by 9 plus 16 plus 144, and this comes out to be, we are simplifying it, 1 minus 13 minus 1, it will be 1 minus 13 whole over 13 squared multiplied by 9 plus 16 plus 144, this is 169. This is equals to 1 minus 13 minus 12 squared, this one is 144 over 13 squared, 169 multiplied by 169 cancels out, square root of 144 is 12. So the value of distance function at point P is equals to 12, right? So distance function P at P point, its value is 12, right? P point is 3 over 13, 4 over 13, 12 by 13, right? So we have to find the value of D function, the distance function at point Q. So we will use this expression again. So we have to find D at Q. What will be the change? The point is minus 3 by 13. So minus 3 by 13, minus 4 by 13, minus 12 by 13. Fine. And we have to find it out. So again 9 comes out. So we have minus 1 by 13, minus 1 by 13, minus 1 by 13. Fine. Rest will remain the same. The common is factor is minus 1 over 13 minus 1 whole squared. Inside the bracket it will remain same, minus 1 by 13, right? And here we have minus 1 minus 13, right? And it will be minus 14 squared, and it will be 14 squared. So in place of 144 we will have 14 squared, right? Minus 1 minus 13 minus 14 squared, that is same as 14 squared, right? And 13 and this 169 cancel out. So in this case the value of distance function at Q is 14, right? So this is minus 14 squared is same as 14 squared, and square root of 14 squared is 14. So we have got dq is distance function, value of distance function at Q point is equals to 14, right? Now since we know in mathematics that 14 is greater number than 12, right? So it means this Q point at Q point the distance is maximum. So this is point of maxima, right? And this point P is a point of minima of the function D function, right? Remember that we have to find the maximum and minimum distance of point 3, 4, 12 from the sphere, right? Remember this was our point, and we had to find the maximum distance and minimum distance of this point from the sphere, right? So the maximum distance is occurring at a point Q lying on the sphere, and its coordinates are minus 3 by 13, minus 4 by 13, minus 12 by 13. And the point that is nearest to this 3, 4, 12 point is the P point, right? So this one is point of maxima, this is point of minima for this distance function, and the maximum value will be value of distance function at Q, and minimum value will be value of distance function at point P. So we have already calculated it. So the maximum distance of 3 4 the given point from is to 14, and the minimum distance is 12. So the maximum and minimum distances of points. So the maximum distance is 14 of this point from the sphere, and the minimum distance is 12. The maximum distance occurring at point Q, and the minimum distance occurring at the point P. So if you understood this lecture, these are two practice problems for you. In problem number 1, you have to find the temperature in a space where the temperature function is given by T equals to 400 x, y, z squared. Find the highest temperature. This is the temperature function, and we have to find highest temperature on the surface of this given unit sphere. So you have to decide which one is the function and which one is the constant, and then you have to find the maximum and minimum value of the temperature, right? Only maximum value of the temperature, right? And the second equation, find the point on the surface. This one is the surface nearest to the origin, right? We have to find the point which is nearest to the origin. So these are two practice problems for you. Thank you.